You know, our planet feels pretty solid under our feet most of the time, but it's a living, breathing thing. And sometimes its movements are, well, they're violent, they're incredibly powerful, and they can be absolutely terrifying. So in this explainer, we're going to dive deep into the science behind earthquakes and tsunamis. We're going to talk about what they are, why they can pop up in the most unexpected places, and most importantly, how you can survive them. So let's just kick things off with a number that should really grab your attention: 90%. According to Japanese government experts, that is the probability that a catastrophic megaquake is going to strike Japan's Nankai Trough sometime in the next 40 years. Think about that. It's not a question of if, it's a question of when.
And look, we're not talking about just any earthquake here. Scientists are predicting a magnitude 9.1 event. Now, that might not be the biggest one ever recorded, but because of where it's located and the tsunamis it's guaranteed to trigger, this could become the single most devastating natural disaster in all of human history. The economic losses alone could cripple global supply chains for years.
See, the Nankai quake is what we call an oceanic quake, and it is so important to understand the difference. Inland quakes, they cause immense damage, don't get me wrong, all that shaking, landslides, but oceanic quakes, they have a far, far deadlier weapon in their arsenal: tsunamis. And that's exactly why their potential for destruction is just so much greater. So to really get a handle on what the future might hold, we have to look back at the past. The history of earthquakes is basically written in these moments of just sheer, unimaginable power. Events that have reshaped not just the land, but the course of human history itself. And here's the crucial thing to remember: magnitude isn't everything. It's not the whole story. The most powerful earthquake ever recorded was a staggering 9.5 in Chile back in 1960. But it actually caused relatively few casualties because, well, not many people lived there. Now compare that to the 1556 quake in China. It was a lower magnitude, but it hit a super densely populated region and killed an estimated 830,000 people. Location, it turns out, is everything. Okay, so now let's get into one of the greatest geological puzzles of all time. We all think of earthquakes happening out on the West Coast, right? Along those big tectonic plate boundaries. But in the early 1800s, the most powerful earthquakes in American history didn't strike California. They struck the Midwest, miles and miles from any known fault line. So how is that even possible? And I'm not asking a riddle here. This is a literal historical fact. There was a force so powerful that it actually reversed the flow of one of the world's mightiest rivers. This was the central, just absolutely mind-bending event of what we now call the New Madrid earthquakes. And for centuries, it demanded an explanation. I mean, just try to put yourself there for a second. Eyewitnesses described a scene that sounds like it's straight out of a disaster movie. The ground itself was behaving in ways that should be impossible. This wasn't just shaking. It felt like the earth itself was coming apart. And here's the kicker. It wasn't just one and done. It was a relentless, months-long assault. There were 3 massive shocks, each one estimated to be over magnitude 7.5, and then thousands of smaller tremors that just terrorized the entire region for a whole winter. So for almost 200 years, the New Madrid quakes were a total mystery. And the answer, incredibly, wasn't found in Missouri. It was found thousands of miles away in a strange dead forest that held the key to a hidden danger buried deep beneath the soil. I mean, this is geological detective work at its absolute best. Scientists stumbled upon this ghost forest of dead cedar trees, and by looking at their rings, they figured out that every single tree had died at the exact same time, in the winter of 1699. And the cause? A massive earthquake and a resulting tsunami that flooded the whole forest with salt water, poisoning the roots. And just like that, they discovered a previously unknown fault line, the Cascadia Subduction Zone. But wait, the Midwest isn't on the Cascadia Fault. So how on earth could a quake that powerful happen there? Well, scientists went back to those original eyewitness accounts, the ones that talked about boiling sand, and it clicked. The cause wasn't a typical fault line. It was something else, something terrifying. It's called soil liquefaction. Basically, when you take wet, sandy soil and you shake it violently, it stops acting like a solid and turns into a thick, soupy liquid. And this, right here, is why that old mystery matters so much today. The entire Midwest region, including major cities like Memphis, is built on that exact same wet, sandy soil. So if another big quake hits, the very ground beneath the city could turn into quicksand, swallowing buildings whole. Your standard earthquake proofing? It's totally useless when the foundation itself just disappeared.
Okay, so we've talked about the cause, the shaking, but now let's pivot to the deadliest consequence of these massive quakes, an effect that can travel across an entire ocean at the speed of a jet plane, the tsunami.
You know, the word itself actually tells a story. Japanese fishermen way out in the open ocean, they wouldn't even notice this wave passing right under their boats. But then, when they sailed back to port, they'd find their entire village just gone, wiped out by a massive harbor wave, a tsunami, that they never even saw coming.
It all happens in 4 stages. First, you get the uplift. A huge section of the ocean floor gets violently shoved upwards by the quake. Second, travel. All that energy creates a wave that's almost invisible in the deep ocean, but it's moving incredibly fast. Third, recession. As it gets close to the coast, it starts to slow down, and all that energy has to go somewhere, so the wave grows to a monstrous height. Often, the very first sign is the ocean itself pulling way, way back from the shore. And finally, inundation. That's when the wall of water hits land.
This story is just incredible. During the massive 2004 Indian Ocean tsunami, a 10-year-old British girl named Tilly Smith was on the beach in Thailand, and she saw the ocean recede, just like she'd learned in a geography class 2 weeks earlier. She started screaming, "Tsunami!" She convinced her parents, and they managed to clear the beach, saving about 100 people. It just goes to show you, knowledge is power. In her case, it was literally the power to save lives. Which brings us to probably the most practical, most important part of this whole thing. We've gone over the science, we've looked at the history, but what do you actually do when the shaking starts or a wave is coming? When seconds count, this is what you absolutely need to know.
Okay, if you are indoors, do not run outside. The mantra you need to remember is drop, cover, and hold on. Get low, get under a heavy piece of furniture like a sturdy table, cover your head and neck with your arms, and just hold on tight until the shaking stops. Stay away from windows and anything that can fall on you. And never, ever, ever use an elevator.
Now, if you're caught outside, your goal is the exact opposite. Get into the open. Move away from buildings, away from trees, away from streetlights. The biggest danger out there is falling debris. And remember, power lines are your enemy. They will come down. Get away from them.
For a tsunami, the rules are different, and they are way more urgent. If you're near the coast and you feel a big earthquake, or if you see that telltale sign of the ocean suddenly draining away from the shore, do not wait. Do not investigate. You run. You run to the highest ground you can possibly see, immediately. Forget your car, you'll just get stuck in traffic. And please remember this, a tsunami is a series of waves. The first one is almost never the biggest. You are not safe until officials say you are safe, hours after the last wave has passed.
So we end on this thought. From the known looming threat in Japan's Nankai Trough to the hidden danger lurking right under the American Midwest, the science is clear. The survival techniques are proven. The only real variable left in the equation is us. Are we ready for the next time the Earth breaks?